Hello, welcome to this webinar, Improving Power Efficiency with Network Site Control for IoT Devices. I'm Markus from Soracom and I will guide you through this technical demo. What will be part of this technical demo? I will give you a short introduction to eDRX. Then we will take a look at the Sony Spresense board, which is mounted on its LTE-M extension. As well, we will take a look at the used Otii ARC measurement device and the Soracom API, which is used to change the desired values. After a short wrap up, we will take a look at the key takeaways. If you ever had the need to change an implemented eDRX value for devices in your field due to maybe changed environments, this demo is quite interesting for you because we will show you how to change the eDRX value for the device via a network side control. What is eDRX in general? eDRX is the extended way of discontinued reception, which is nothing else than switching off the receiver part of a cellular module. And due to this deactivation of the receiver part, you will save power. By default, this is every 1.28 or 2.56 seconds in a standard LTE network. And to be able to extend this time to, for example, 5 seconds, 10 seconds, or up to 43 minutes, eDRX was introduced into the standards. Taking a closer look to the eDRX timing now, we will see the power consumption over time behavior. For a device which is not using any eDRX, you can take this idle mode on the right side. So we have a specific power consumption over time, and within that time the UE is reachable. So when we activate or enlarge the eDRX setting now, we will deactivate the receiver part for a specific time, and then it will be activated again for a specific time. So the deactivation cycle length is the eDRX cycle length, and within the so-called paging time window, the receiver part is enabled and is able to receive data. So we've got a non-reachable part then when we activate eDRX, and a part where we are reachable, which is within that paging time window. Which tools do we use in our setup? So we do have the Sony Spresense microcontroller board, which is programmed in our example via the Arduino GUI, which is mounted to the LTE-M extension board. That board has an onboard antenna, for example, and contains a SIM slot in which we put the Soracom SIM. This pack is able to connect to LTE-M networks worldwide and of course use the eDRX power saving functionality. The whole setup is powered by Qoitech's Otii ARC, and we use that device and its GUI to visualize the changes and the power saving functionality on the Sony Spresense. And of course we use the Soracom SIM card, which is inserted to the LTE-M extension board of the Sony Spresense, as well as the Soracom console and the API. There are some prerequisites to be considered. The device and the visited cellular network need to support eDRX. Some network operators define a minimum eDRX value. We would not be able to be below this minimum value. And of course the device itself needs to have eDRX enabled. So the key feature now is that we will push eDRX values to a device via an API call. This is done via this normal network behavior that the network is a master and will override the requested value from the device. This will give us a possibility, especially for old implementations, to anyway change the eDRX settings. Finally, it gives us a flexibility in the application setup. We are able to lower the power consumption, extend battery lifetime, and have some cost savings. The Soracom API can be accessed via its GUI or via a simple command shell. To set the values, we will use the put configuration parameters command, and we need to enter the related group ID as well as the requested values within the body section. And after pushing the values, we will see the reply of the API if the values are adapted accordingly. So what will happen after we set the values via our API? The UE, the Sony Spresense board, as soon as it's powered on, it will attach to the LTE-M network, and this will cause an update location request to the Soracom HSS, which is kind of home location register. In the answer to that request, we will put the desired values, which are then delivered to the Sony Spresense board in the attach accept message. So, and how can we be sure that the device is setting the requested values? Of course, this is only possible via a suitable measurement device. In our example, the Otii ARC from Qoitech. This is the Sony Spresense board with a soldered plug for the power supply. At the bottom is the LTE-M expansion board. You can see the module here, and I will insert the SIM card to the SIM card slot. That's it. Now I will connect the power cable to the soldered plug like this, and we are able to plug these power supply cables now to the Otii ARC. Plugging the power support cables into the Otii ARC is not a big issue. Just red on red and black on black, like this. So this is our setup. Now I will show you the technical demo part. On the upper left of the window, you see the hardware setup, the Sony Spresense board mounted to the LTE-M extension board with the inserted Soracom SIM card, powered by the Otii ARC. On the left side of the screen, there is the Otii ARC application, where I can activate the device and start a recording. On the upper right, we have the Soracom console showing the status of the inserted SIM. I called it Spresense, which is assigned to a group called eDRX2. And in the lower right, there's the GUI of the API, which we use now to check which eDRX values are configured in the moment. As well, I've opened the harvest window because the application which is running on the Sony Spresense board will connect to the network, read the value of the eDRX which is set, and will pass it to Soracom Harvest. So currently, also in the last run, the eDRX value 13 and the paging time window 3 was passed to Harvest. So let us check if this is still the configured value. For this I need the group ID of the assigned group. This is the group ID. Copy it and search for the group functions. I take get group, insert the group ID and fire. And what we see here is the paging time which is set up and the eDRX cycle length, which is exactly what we saw on Soracom Harvest 13 and 3. Let us now adapt these values and start the device. For this we need to use the put configuration parameters function. I paste again the group ID and the namespace is Soracom Air. I'm entering the values which should be set. So I want to set eDRX cycle length value 3 and paging time window cycle length 3 as well. What are the values of this setting? The eDRX cycle length value was 13, so one eDRX cycle was 2021 seconds long. Now I change it to 3, which is 40 seconds. And the paging time window I want to change to 3 as well. So the paging time window will be 5.12 seconds in the wideband LTE-M mode. Okay, so I fire this command and I see a positive response, which with the changed values. If I now power the device, the changed values will be pushed to the device in the answer to the attach request. Okay, so let us check this. For this I will start a measurement and I will power on. Now we see that the device is starting. With these controls I can mark an area, for example, and extend it and shrunk it. Okay, device is started. This is the connected DX phase, and now it's already in RRC release status, so not connected anymore. And here we see our first paging time window. If I check Soracom console, it shows me the online status of the device. And if I check Harvest, there is the new data push eDRX3 paging time window 3. So let us check if there's already the second paging time window. And as we can see, the paging time window is exactly as requested, 5.2 seconds. And between two paging time windows, there should be the eDRX cycle length, which is 40 seconds. Yes, so in case we push another value, of course, the changed value will be displayed here. To shorten this a little bit, I already recorded different paging time windows and eDRX values. For example, eDRX value 8 and paging time window 3. So the paging time window is the same as in my last measurement, 5.2 seconds. Or eDRX value 7 and paging time window 7. eDRX window 4, paging time window 6. As you can see, the device is adapting to the changed values, which shows that we are able to change the eDRX values from the network via an API push. If we are now comparing the different measurements, let me enlarge this application. Let me first show you how it looks like without any eDRX. So this is how the power consumption is looking like without any eDRX setting. So the standard value from one peak to the next is for LTE-M 1.25 seconds, and if I mark a sample time frame, let's take 1 minute and 30 seconds, for example. Within that 1 minute and 30 seconds, you can see in the upper right corner the energy consumption is 1.45 milliwatt hours. So we are even able to move this, and it's always around 1.4544 milliwatt hours. Let us now use the first eDRX value, which I recorded here. Here you already see the difference. Where eDRX is active, there are no receiver peaks anymore. And in the paging time window time, we see the receiver peaks. So having this value set within the same time frame, it's still 1 minute 30 seconds. We only have 1 milliwatt hours power consumption. We can move that from, so it's always around 1 milliwatt hour. Let us enlarge the eDRX value. Okay, catching two paging time windows, checking. Small reduction only, but it's less, it's 986 microwatt hours. Let us take another one, eDRX 8, paging time window 3. As you can see now, it's not possible anymore to get two paging time windows within our 1 minute 30 time frame. That's why we only can take one, and it's going down to 950 microwatt hours. And there's even a more simple way comparing the different measurements. You just need to click and activate all these measurements here, and then go onto the upper right corner, and here you see the comparison for the selected window exactly all at the same time. Wonderful. So what are the key takeaways? The power saving capabilities of eDRX might not be that drastic as the ones archived via PSM, where the whole device is put into a sleep mode, but every single piece counts. So the more you are able to reduce the power consumption via eDRX, the longer the battery will last, and the better your carbon footprint of your IoT application will finally be. eDRX is mainly good for devices which are mainly sending data and rarely receiving them, because we disable the receiver part. And especially devices which need to adapt to certain conditions, they will benefit from being able to adapt the eDRX setting via this API push. This is a link to our Soracom store, where you are able to purchase the used device together with a Soracom SIM within the available countries. If you are interested in the used power analyzer, the Otii, or you are searching for information regarding power analysis, battery testing, or battery life estimation, visit our partner's website, Qoitech.com. If you are searching for more information about Soracom, or you want to get connected, just visit us on our website, Soracom.io. We can arrange a consultation with a specialist. You can set up your account and start testing right away. As well, you can check out for our blog and other webinars which are available.